Hello all, welcome to the today's video on operations on graph, which is a continuity of the past video. Today we will see what are the different operations that can be performed on graph. Some of the operations that can be performed on the graph are listed below. Traversal of graph. Here we can do the traversal where we can visit the vertices or the edges in some order. The second operation is insertion of a vertex or edge in the graph, where we can insert any vertex or an edge. Similarly, we can delete any vertex or edge from the graph, which is a third operation. The fourth operation is we can search whether there is a vertex or an edge that can occur among the two vertices. These are the following operations that can be performed on graph. Let us discuss about the operation of graph traversal in detail. What is traversal? Traversal is nothing but a process of visiting edges or vertices all at once. Here we use some color codes. It is very important to note down. We consider three colors. For undiscovered state, it is white color. For discovered state, it is gray color. For processed state, it is black color. What is undiscovered state? When a vertex is new and we have not visited it, it's going to be called as undiscovered state, and we would represent them in white color. What is discovered state? Discovered state is nothing but we have just reached the vertex and it is yet to be processed, is nothing but the discovered state. The color of this state is represented using gray color. What is processed state? We have reached the vertex and the vertex is processed completely. That is represented using black color. So these are the color codes which has to be known for the further traversal. Graph traversal can be done with the help of two types of data structures. One is queue, the other one is stack. Queue. As you all know, queue is nothing but the first in first out order, that is FIFO order. Here, the oldest unprocessed vertices are considered first. The second possibility is using stack, which is operated using the technique last in first out, nothing but LIFO order. Here, we explore the vertices by moving along a path. Using these two possibilities, we are going to do the traversal in two different ways. One, it's going to be breadth first traversal. The other, it is depth first traversal. Kindly make a note that breadth first traversal is done using queue and depth first traversal is done using stack. Now, it is time for us to understand both the breadth first and the depth first traversal. Let us move on. Here we come, the breadth first traversal, which is also called as breadth first search. This algorithm is much important and can be referred in many other papers like artificial intelligence and computer network. The core operation of this algorithm is same throughout the different subjects. Let us move on in data structures what BFS define. The first step, at initial stage, all the vertices are undiscovered. As I had already told you, the color code for all the undiscovered vertices are white. Second step, change the state of the starting vertex X to discovered and add it to queue. As I had told you, BFS uses queue. So the first step is to start with the start vertex S and make the start vertex as discovered and add it to the queue. As I have told you, the color code for discovered is gray. Now, let us move on with step 3. Repeat the following steps while queue is not empty. As you can see, we have added the start vertex to the queue. So, we have to repeat these steps, that is this step and this step, till the queue is not empty. Now, let us see what happens inside these steps. Remove vertex V from front of queue. Point to be noted, the deletion is done from the front side of the queue. And set it to processed. Initially, the start vertex S is at queue. So we would remove this and we would make it as processed. Thus, it would become in black color. Repeat for all undiscovered adjacent vertices u of v. So the similar process has to be done with the undiscovered adjacent vertices. Here you can see V at the initial stage. V represents the start vertex S. So we are going to take the adjacent vertex of S and make it as undiscovered and repeat the process. So what process is repeated? Every adjacent vertices are set to discovered and added to Q. So by this way, we repeat this process again by taking a vertex from the front end, making it processed, inserting all its undiscovered adjacent vertices, again make one of them as discovered. So this process repeats. This is the core of this algorithm. It is repeated till when? Till the Q is not empty. Do not worry if it goes complex. Let us see with an example to make it simple. Let us move on with an example of breadth first search. For your indication, I have represented the Q, which means that BFS uses Q for its processing. Let me consider an example of directed graph. It would be best to write the adjacency list of this node. In the algorithm, I require the adjacency vertices. That's the reason it would be best for me to write the adjacent list of nodes side by side. Here it goes, the adjacency list of nodes. Now, let me take a Q. Here, I would like to represent the Q in the form of an array. So, how much the size of the array should be? You know, we are actually traversing the vertices. Thus, here in this example, I have 5 vertices. So, I need 5 space in this array. So, one for A, B, C, D and E. Let the indexes be 1, 2, 3, 4 and 5. Now, let us move on. As you can see, my vertices are all in white. This is the rule of our algorithm. At initial stage, all the vertices are undiscovered. As I had already told you, the color code for undiscovered is going to be white. And for discovered, it's going to be gray. And for processed, it's going to be black. Now, at the initial stage, all the vertices are undiscovered. As you can see, I have not given any color to the vertices. Now, let us proceed. Since it is a Q, you know the front and the rear. Initially, at this stage, front and rear are null. So, front I would like to represent with F. F is null and rear is also null. At step 1, at initial stage, all the vertices are undiscovered. Yes, I have done them as undiscovered. They are white. And I have to change the starting vertex S to discovered and add it to Q. So I have to change the color of the starting vertex. So here I have to consider some vertex as starting vertex. Let me consider as D. So I would like to start from D and I have to traverse. So let me my start vertex as D. If there is no start vertex, you can select such a vertex from where you can traverse further. D is the start vertex. I have to consider D as discovered. Let us move on with the algorithm. Change the state of the starting vertex S to discovered. So make it as gray and add it to the Q. So make it gray. So D, I am making it as gray. And now I have to add it to Q. So the first value would be my start vertex D. Here the front is 1 and the rear is 1. Now let us move on with the next. As I have started with the first node, next what I have to do? Repeat the following steps while the Q is not empty. Remove the vertex V from front of Q. Now let us move on with the Q. Here in the Q, only one node is there, D. Remove it and make it as processed, nothing but black. As you can see, from the front of the Q, we have to remove the vertex and set it to processed. nothing but black. Repeat for all undiscovered adjacent vertices. So after making this as processed, I have to write down all the adjacent vertices of U and make it as discovered. That is nothing but the white color, and add it to Q. So now let us move on to the example. So in the example, I have to make D as processed. So I am making D as processed. So it is in black. Now I have to check all its adjacent node. Adjacent node of D is nothing but C. So if you guys see, the adjacent node of D is C. So I have to insert this C in the Q. As you have seen, when D is made as processed, this D is removed from the queue. Now when I add C, the status of the queue will be like this. So the C is placed over here, where front is 2 and rear is 2. D is indirectly deleted. Now what happens to C? Discovered. The color code for discovered is gray. So let me change the color of C. Now it is in gray. Let us move on with the algorithm. In the algorithm, I have made the adjacent vertices as discovered and I added to Q. Now what should I do it again? I have to repeat this process again. But as you see, D has only one adjacent node. So this loop stops till here. Now we have to go to the outer loop. What is the outer loop? Outer loop is again the same. Check whether the queue is empty or not. Queue is not empty. So remove vertex V from front of queue and set it to processed. So now what you have to do? Remove the node from the front of queue and set it as processed. So who is at the front of queue now? At the front of queue is C. So now I have to make this as processed and have to bring all its adjacent nodes into the queue one by one. Let me make the node C as process and let me remove it. Now after I remove this, node D was already deleted, node C is already deleted. After this, I have to insert the adjacent node of C. Kindly note down there are two adjacent nodes of C. Insert that in the queue. So one by one you have to do the insertion. First it would be A, second it is E. Now kindly note the front and the rear. Front value is 3 and rear value is 4. Now which one will be the first thing to be deleted? Of course, deletion starts from the queue at the front end, therefore A will be deleted. Now repeat the process, make A and E as discovered. So when I make A and E as discovered, both of them will be appearing in gray color as per the color code. Now since A and E are discovered, I have to remove one by one the nodes from the queue and make it as processed and add its adjacent node. So now which one will be removed first? Of course A, since it is the first item in the queue. Now make A as processed. Okay, I have to change the color code. So A is processed, remove it from the queue. When A is removed, of course front will be shifted. So now front is 4 and rear is also 4. When A is deleted and it is processed, its adjacent nodes has to be added to the queue. So A's adjacent is B. So B is now discovered. Change the color code of B. So the color code of B is nothing but gray and insert it into the queue. So it's going to be B here. Now you have to change the rear value as 5. It is not 4 now. The rear is 5. Now if you see the queue is not empty, so take down the first node that has to be processed. So if you see, front is nothing but 4, so we can do the deletion from front, which is E. Now make E as processed. When E as processed, you have to delete it, of course. When E is processed, you have to delete it from the queue. So let me rewrite the queue over here. E is deleted, and make E as processed. Okay, I'll be making E as processed. And now I have to insert the adjacent nodes of E. Point to be noted. A and D are adjacent nodes of E, but A and D are already processed. Therefore, you cannot insert them into the queue. Only the nodes that are undiscovered can be inserted into the queue. That's it. So no further insertion happens. Now, let us move on with the last node which is there in the queue. The last node is nothing but B. Process it now. So turn the color code of B as black, delete it from the queue, and check for its adjacent node. B's adjacent is E, but point to be noted, E is already processed, so we cannot insert it. So now if you guys see, the queue is actually empty. When the queue is empty, let us move on to the algorithm. You have to start the process only when the queue is not empty. But as you can see, the queue is empty. That's all. We have traversed all the vertices. So the order we have traversed using BFS is D, C, A, E, and then B. So this is a traversal which we have done through breadth first search. That's all guys. Now we will move on with the depth first search, where we will be doing the traversal with the help of stack. Point to be noted, it is last in first out. Now let us move on with the depth first search. Depth first search is similar to breadth first search, just the minor change is that we will be using the stack. Step 1. At initial stage, all the vertices are undiscovered. As we have already seen, this is the same step in breadth first search. You can see over here, the same step is there in the BFS. The color code also remains the same. Depth first search step 2. Change the state of the starting vertex as to discovered and add it to the stack. This step also remains the same as compared to the breadth first search. As you can see over here, just instead of queue, we are using stack in depth first search. Repeat the following steps while stack is not empty. Same step as the top of the breadth first search. Pop a vertex V from top. There it was queue, so we used to delete from the front side. Here we would be deleting from the top of the stack and set it as processed. After that, repeat all the undiscovered adjacent vertices of U of V. What we have to do, we have to take the adjacent vertices of U and we have to make them discovered and push it onto the stack. The same process as we had did with the breadth first search. There we used to repeat these steps when the queue is not empty. Here we have to repeat it till the stack is not empty. Now let us move on with an example. Let me consider the same example of directed graph. Again, we would need the adjacency list of nodes. These are the adjacency list of nodes. Now let us start. So in this example 2, I would like to start the vertex from D. So let my start vertex be D. You can take any start vertex. Just check that doesn't becomes a sync. Now, as per the algorithm, I have to push the start vertex into the stack. So let me consider the stack. I have to push the start vertex D onto the stack. So you know the top pointer will be pointing to D now. As I push D, it is something like I have discovered. So I have to change the color code of D from white to gray. Now, after this, I have to pop the vertex which is at the top of the stack. So D is popped. Now, what I have to do, I have to make this D as process. After making this D as process, its adjacency nodes has to be pushed onto the stack now and make them as processed. So now I have to push the adjacency node C. Now the top would be pointing to C and I have to make it as discovered. So the color code for discovered is nothing but gray. Now, at the top of the stack, again C is there. I have to process it. Therefore, pop it from the stack. And now, I have to place the adjacent nodes of C onto the stack. So, I have to place it as A and then E. Now, top would be pointing to E. This would be the recent item we have inserted. Top points to the recent item. Now, I have to make A and E both as discovered. Therefore, the color code would be gray. So, A is gray and E is gray and C is already processed. Therefore, we have to change the color code of C to black. Now, you have to start processing the vertex which is at the top of the stack. This is the difference of the BFS and DFS. Here we would be selecting E. Therefore, E would be the first thing that has to be processed. So, E is processed. If you note, when E is processed, its top is shifted to A. Now, after E is processed, the adjacent nodes of E are A and D. Now, the only value on the stack would be A. Why? Because the adjacent node of E is A and D. Point to be noted, A is already on the stack and it is discovered so that you cannot push it onto the stack again. And D is already processed, so you cannot push it again onto the stack. So now there would not be any value to push it onto the stack. So the top is A. So now A. So remove A. Nothing but make A as processed and remove it and push its adjacent onto the stack. So the adjacent node is nothing but B that is pushed onto the stack and therefore top points to B. Change the color code of B to gray since it is discovered. Now, the only value on the stack is B. Therefore, process the stack by changing the color code as B and remove that from the stack, and therefore there will not be any value to insert onto the stack since the adjacent node of B is E, which is already processed. When the stack ends, the algorithm ends, which we have studied here. While stack is not empty, we have to repeat the steps, but now my stack is empty. That's all, we have completed the traversal. So in which order we have traversed? We had made E processed first, then C, then E and A and then B. So this is the traversal that has been done with the help of DFS through the help of the stack. That's all guys, we have seen both the traversal, that is BFS and DFS, with the help of queue and stack respectively. If you have any doubts, please feel free to comment. Kindly like, share and subscribe. Sharing knowledge is not a crime. Thank you.